Hi guys, it's Mrs. Burgess, and instead of watching the old lady in her safety glasses, you get to watch me without my glasses. I mean, I guess I could put on my sunglasses because the sun's electromagnetic waves are so bright in here. No. Okay, so today we're going to talk about heat transfer, and we've already reviewed this with radiation, convection, and conduction, but I thought, why not do a kitchen experiment so you could watch me? So I've got here my bowl. I guess this is a pot. This is a pot. Can you tell I don't cook very much? Okay, so I'm gonna fill it up with some water. There goes water. Just room temperature. Actually, it's a little cold. Waiting for the pot to fill with water. Okay, great. Now it's done. Okay. So, maybe I put a little too much. Pour some out. Okay. So I'm bringing it over here to the stove. On the stove. And I'm going to heat up the oven. Okay, so right now, our heat source is down there glowing. Much like the sun is our Earth's heat source, for the most part. Yeah, let's just say it is. This is 6th grade science anyways. Okay, so the sun is the Earth's heat source. And right now my little burner right here is the heat source for my pot of water. And because in here right now we have a liquid, we're going to soon be adding a gas to it. And right now you're thinking, gas? Like from cows, Mrs. Burgess? No. We are going to add enough heat that the water molecules start moving around, and we are going to turn our liquid water into a vapor. No cows involved in this kitchen experiment. Okay, so we're going to let that go, and while that's going on, why don't we just take a look around the house? So this is my kitchen. Here comes my Christmas tree. I love Christmas time. I just love lights, right? Like the lights are just so happy. Maybe I'll leave it up all year. I'll be that neighbor who has their Christmas tree lights up all year. Rosie's outside. Let's go see what she's doing. Hi, Rosie. Hi. Rosie, moving around too much. Oh, well, hello, girl. She's very excited to see it all. Okay. I doubt it's boiling, but let's go check on our water. Nope, not a thing. I don't know how to turn the camera around when I'm recording like this, so I'm just going to have to keep flipping my phone. So right now, the heat source, again, down here at the bottom. So if I were to put my finger in here, testing, I don't think the lady with the goggles would have done that. At least not with her bare finger. She'd probably have a glove on. That was like all the way up her arm. So putting my finger in here, this water is nice, but not too hot. If I were to put my finger closer to the bottom of the pot, it would definitely be warmer. So right now I can tell you the warmest part of the water is going to be closest to the burner, where the water closest to the top of the pot is going to be the cooler temperature. And I'm literally watching water boil. Boring. All right. I guess we can walk around some more. So here's a picture of my husband. That's Bo. That's me. That's Bo. That's us. And that's him in, whoa, where's his shirt? Whew, sassy. Okay. I have a thing for nutcrackers at Halloween. It's not Halloween. Old age. At Christmas time. This is Albert Einstein. He sits at my coffee pot. So we have a little chit chat in the morning like, hi Albert, how's it going? Good. Just another day, cracking nuts. And solving equations because he's got a ruler. He must be taking notes in his composition book. He's got a notebook and a ruler. Albert, love that guy. And then I have a little fishing man because my husband loves to fish. I would try, but the cold water always like every time I get in a cold river, I have to go to the bathroom. So fishing doesn't really work out for me. Okay, so this is my little fisher dude. And his little mouth moves. And he's got a little fishing pole and some fish. And then there's like just this little dude. I think I probably picked him up for free somewhere. I don't know. He's just little. He's a little guy. Boiling? Nope. Is the thing on? Turn it up a little higher. Then we have Frosty, a little snowman. Boy, is it cold. He doesn't even really have a mouth because he's a snowman. But it's like this hole right here. I guess you could put a nut if you need to. And then you've got like your traditional looking nutcracker. Yeah. Always cracking nuts. Oh, look who's just sitting so nicely. Hi, Rosie. Oh, I see your tail wagging, sweet little puppy. Yeah, I know you want a treat. I would like a treat. The treat would be my water boiling in my pot. Oh, I hear noise. Okay, something's happening. Oh, what if I put it like this? And then you can see me and the pot. Hey, look at that. So techie. Okay, so let's, I'm spilling stuff up. Maybe I do need goggles. Okay, so here's back to what I was saying. Hottest part of the water is closest to the pan. Also the water that's spilled out of the pan that is now cooking on my countertop. Colder water's up top. Still not too bad on my fingers. Pretty soon, we're going to have what's called, oh my gosh, so much. Ooh, this is like a situation. Okay, water molecules. The water molecules are very angry that have spilled onto the countertop. I do not recommend you do this at home by yourself. Without safety goggles, some gloves, and probably supervision. Okay, so let's talk about convection with a V. So think of V as in the number 2. You need 2 things. So you're dealing with a liquid and a gas. So here, all the convection of the liquid and the gas actually happens in the water. It's all happening in the water. Ooh, I got some water vapor. Can you see that? It's very spooky. Okay. We've got water vapor coming out of the, what about I put it over here? Okay. We got water vapor coming slowly out of the top of the pot. So what's happening right now is inside that water, if we were a little molecule, like, what's that science lady who rides the bus, who gets really small? Anyways, she has like a lizard as a pet. I don't know. So anyways, if we were a molecule in here and we were a hot molecule, we're getting hot, we would be the hottest, again, closer to the burner. We would be moving really fast, quickly going from a liquid to a gas. There's your 2, liquid, gas. And as we move up, the colder, we're going to push that cold molecules that are at the top of the water. They're going to have to get out of our way because we're moving so fast. And they're going to actually move, and then because they're colder, they're going to start sinking. They're going to go take up the room that we just made for them. So you're going to get like a circular loop of warm molecules rising to becoming a gas, and the colder water that's on top is going to sink, taking up the space that was just made by the gas, and it's going to keep rotating in there in a loop-like pattern. That's convection. 2 gas and a liquid working together in a loop-like rotation. As they rise, the heat rises and the cold sinks. Okay, things are happening, people. Okay, so now I've got, you know it, ramen. Who doesn't love a little ramen? I have to admit, I really like ramen, but I don't like all the seasoning. It's a little too salty for me. Yep, a little too salty. Maybe I'm a little too salty. Probably. Okay. Oh, making a mess. Rosie will get it. Okay. Noodles. Putting them in. Oh, people, look what's happening. Oh my God, seriously, how do you turn the thing around? I don't know. Okay. I hope you see those bubbles. Those bubbles, that's the liquid that got warmed up by convection down after, in the water there. It got warmed up. It's turning into a gas, starting to reach the top of the surface, pushing that colder water that's on top down to take up its space so that it can become a gas. I'm putting it in my noodles. Noodle. Oh my God, you guys are gonna all be nauseous from like watching my screen go around. Okay, so that is convection. Convection is happening in the pot right now. Now let's talk about about conduction. So conduction is direct contact. D, conduction, direct contact. So right now, we actually have both happening here. We've been talking about in the pot, but if we actually talk about the pot itself getting warm, it's through conduction. D, direct contact. Right now, it is direct contact with the glowing, radiating heat from the stove. I will not be using my hand to prove that it's hot, because it is. So conduction is happening between the burner and the pot. Convection, liquid and a gas, is happening in the pot, warming up the looping of the cold water, the warm water, the gas, the, excuse me, I itch, liquid, looping as it warms up the water. And now, I need a fork. Fork. Ooh, I think I have a little too much water in my noodles. I'm going to have to drain some of that out. Now there's lots and lots of vapor coming out. Another thing, heat rises. So all the cold air that was here when I started cooking, it's going to go up, and it's going to take the place of where these molecules, and make a kind of a circular rotation like this. The warm air rises, the cold air sinks around it, and then moves in this formation. Holy moly, just when I thought I taught it all. Look, can you see? Oh, that's going to be hard to see. Can you see what's happening right here? It's getting moist. I really don't like that word. It's getting damp on my microwave because the hot water vapor is found a surface or particles in the air, and it's condensing. We've got condension. I think I just put like 3 words all into one. It is condensing, people, right here in my kitchen. All this is happening. Conduction, direct heat. Convection, liquid, gas, and noodles. Water vapor, rising, heat rising, finding a surface, mixing with particles in my air, causing condensation. And if this kept going for a long period of time, we'd have water droplets that start coming down. Hi, water cycle happening right here in my kitchen. Anna, mind blown. Okay, I think that's it for now. That's a 13-minute video. Wow, that's really long. Bye, guys.